Okay, the prices of 7 race cars sold last week are listed in the table below. What is the mean value of these cars, and what is the median value of these cars? So the only thing tricky about this, I think, is that right, there's a frequency associated with each number. So you wouldn't just deal with 126,000 once, and then 140,000 also once, because 140,000 is actually listed twice. So with this, in this case right here, I'm going to use the graphing calculator. I'm going to quit this right here. So I want to enter these numbers into a list. So I hit, over here is a stat button, and notice if I press that, I can edit my list right here. I have some lists set up. I'm going to clear them. I go to the top heading, hit clear and enter. That clears my data. I'm going to do that for everything I have right here to have a nice clean start. So again, I'm just hitting clear and then enter. Okay, so now I'm going to enter this data. So enter 126,000, right? That's my first one. Okay. Then I enter 140,000, and I'm going to do that twice. So it's 140,000, then 140,000. Okay. And then 180,000 once. Okay. And then 400,000 twice. Sorry, it's a little slow. One more time, 400,000. Okay. And then 819,000 once. Okay, so this data is now entered into a list. I want to calculate with that. Hit second stat, and see this math over here. You want to scroll over. Mean is the third one. Hit 3. So I want to find the mean of list 1. Hit second one, and it will give me that value. Here, though, and this isn't what it gave me the value in the list. I don't like that. Delete that value. But quit out of this because that looks too confusing for you. Sorry. So I'll hit second stat again. Scroll over to math. The mean of list 1. Second one is list 1. And here's my mean. So 315,000. Okay, so don't forget we entered the frequencies of each item. The median. So this is nice and easy now. Second stat. Math. Right? Median is the fourth option. The median of list 1. Second one is 180,000. Okay. State which of these measures of central tendency best represents the value. Justify your answer. Okay, so if we look at the spread of the data, it goes from 126 all the way up to 819,000. But most of the data is clustered within the $100,000 range, and there's 400,000 and 819,000. So the 315,000 I wouldn't actually pick because that overrepresents 3 of the cars, 3, 4, 5 of the cars, and underrepresents 3 of the cars. Instead, I would pick the median because of the this outlier, the 819,000, kind of throws the mean off when you add them and divide it. The median is not thrown off by that. In fact, the median is pretty close to exactly what one of the cars is, excuse me, but also pretty close to the other 3 cars. It is way below the other 3 cars, right? But still, I like the fact that it's closer to 5 of the cars. I'm going to personally pick something that's closer to 5 of the cars than not exactly close to any of the cars, right? If I walked in with 315,000, I really can't buy anything close to the price range. There are cars only above my price range and cars way below it, but nothing next to it if I walk in with this amount of money. Although if I walk in with $180,000, I am dealing with cars that I can purchase. And of course, if you're purchasing cars for this much, I guess money is not really something you're worrying about anyway. So let's move on. Okay, the table below shows a cumulative frequency distribution of runners' ages. According to the table, how many runners are in their 40s? All this does is, in 20 through 29, see there are 8 people. So I'm going to just write a regular frequency tally right here. Notice the 20 through 39, it includes the previous group, right? So we're adding on. So now there's the 8 from before, and now we have 18. So that means we added 10 more in this range, right? So cumulatively there are 18 in total, but there are 10 more in this group. Next there are 25 in this group, so I had 18, now I have 25, that's 7 more. So there are 7 in this group, and it keeps going. To get to 31, we have to add 6 more, and 35, 4 more. So the cumulative frequency just keeps adding all these groups. A regular frequency just tells you how many there are in each group. So how many are there 40s? So the 40s range, right, is 20 through 29, that's not that one. 20 through 39, we're not there yet. 20 through 49, this is our group right here. That includes all the people from 20 through 49, those 25 people. But there are 7 distinct people in that range, so our choice is 7. The next one. Which data set best describes a situation that could be classified as qualitative? So quantitative, the opposite of qualitative, right, is about numbers and measurement. Qualitative is about measuring quality. So here, the opinions of students is a qualitative measure. And all these other ones, the shoe sizes of players, we can measure that with a number. So that's quantitative, quantity or number. So is choice 2, the ages. Right, ages and shoe sizes and elevations, all those things that are measured with number or quantity. They're not qualitative. Okay, next one. There's a negative correlation between the number of hours that a student watches TV and their social studies test scores. Which scatter plot displays this correlation? So negative correlation is, right, however this is set up and however this looks, the negative correlation, right, be clear about this, is the x and y axes. As x increases, y decreases. That's what a negative correlation looks like. So any graph we look like a trend should be essentially going down in height as x is increasing, which is number 4. Every other one, like this is a positive correlation, this is a 0, this is really no correlation because it's just all over the place. So here I pick number 4. What is the value of the third quartile? Well, this is something you have to know. The second quartile, or median, is this line always in a box and whisker plot. This is the first quartile. The median splits the data into 2 equal groups, 50% below, 50% above. The first quartile splits the lower half into 25% and 25%. This is the minimum value here. And the third quartile is always this line right here, which splits the upper range into 2 groups, right? So that's the max. So this is literally this number, which is 10. They might call it the third quartile or the upper quartile. The lower quartile or the first quartile is always this line right here. Okay, let's keep going. Right. Which equation most closely represents the line of best fit? So we can enter all this into the calculator. That'd be super tedious. I'm just going to graph these lines. So y equals x. Right, you can see y equals x. So all the points where y and x are equal is not even close. This is the line y equals x. It's really an unbalanced line of fit. Okay, that one's out. Now we have 2/3, 3/2. Let's do 2/3 plus 1. So graph that in blue. So here's 1, and the slope of 2/3 just means up 2 over 3. Up 2 over 3, up 2 over 3. You can see that this slope brings us a line that is even worse than y equals x, and that was y equals 2/3 x plus 1. Alright, so it's going to be one of these two. Let's try the next one. Y equals 3/2 x plus 4. So 4 is the y-intercept. 3/2 means that's a slope up 3 over 2, up 1, 2, 3 over 2. And this line actually also looks terrible. So I'm hoping choice 4 is the closest. But if it's not, right, if it's also worse off, we'll pick one of the less. We'll pick the lesser evil out of the ones we're given. Okay, so 3/2 x plus 1. So here we'll graph this one in green. So again, the plus 1 is the y-intercept. We're here, and it's 3/2. So it's up 3, 1, 2, 3 over 2. Up 1, 2, 3 over 2. Up 1, 2, 3 over 2. Okay, so if we connect these dots, I think we get a much better fit. The red line, the y equals x, it's only these 2 points down here are pretty close to it, but everything else is really far away. The green line is somewhat balanced between the points. And in fact, I don't really feel like any of these are really the line of best fit, and would be surprised if they were. But I would say that this green line here is closer than any other one, so I'm going to pick 4. Okay, the next one. 20 students were surveyed, and here's their survey data about the number of days they play outside. Complete the frequency table. Okay, so the first interval is from 0 to 1. So that's this student right here, 0 and 1 and 0. So 1, 2, 3 students. Okay, next one. So those are crossed out now. 2 to 3. So here's 1, that's 3, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. Okay. Next we have 4 through 5. Okay. So 4 and 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And last but not least, we have 6 through 7. 1, 2, 3. 1, 2, 3. And I'm just going to compare this, right? We should have 20 in total. So 6 plus 3 is 9, plus 7 is 16, plus 3, is 19. We're missing 1. Gotta go back through it. And this happens to me all the time, but okay. So 0 through 1. We have 0, 1, 2, 3. So I agree with that. Next one, I said 7 for 2 to 3. Let's check that. 1, 2, 3, 4, 5, 6, 7. Okay. Next one, 4 through 5. 1, 2, 3, 4, 5, 6, 7. Oh, that's what it is, 7 as well. So we'll fix that. 7, 7. So I don't usually cross these out. I just kind of underline them first and then cross them out once I verify. Cross them out if I need to verify where the missing number is. You don't want to write all over them and then find out there's a mistake. Next, we do a cumulative data. So this is easy, right? So we have 3 in the beginning, and then in total from 0 through 3, we have 3 and 7, or 10. 0 through 5, it's all of these, 7, 7, 3, or 17. We're just adding as we go. And 0 through 7 is everything. It's going to be everybody, or all 20. And now we need to plot this on a graph, which is actually nice and straightforward. So here, our x-axis, let's say, is this, right? And our y-axis will be this height right here. So on these kind of diagrams, the frequency is going to be your x-axis. Oh, sorry, the frequency is going to be the y-axis. And here are going to be the intervals. And our title is going to be, what was it again? Keep it simple, number of days playing it outside. So days outside. Okay, so our first number ranges from 0 through 1. So I'm just going to put a 1 here. This is 0. Then 2. Then 3, 4, 5, 6, 7. So this is, these are ranges. And I'm saying that this first range right here is from 0 through 1. And that range that we have here is 3. So we go, right, we go all the way up to 20. So I'm going to go up by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So we have to go up and estimate a little bit here, but 3 would be right here, let's say. So that's our first one. Then there are 10 people in the next group, right? We're adding them as we go. So change my color there. This is a cumulative, right, histogram. And next we have 17. So 12, 14, 16, 17. Here's my line tool here. You should be definitely using a ruler. Don't draw this freehand. It'll be all over the place. Okay. Oops, I made a mistake, I think. Yes. Oh boy. Let's go back. It's interesting. Sorry I missed this. So notice the intervals are not structured in a uniform distance, right? We have 0 through 1 and then 0 through 3. It kind of throws you off a little bit in the way this is structured. So 0 through 1 again is, going back, it's going to be 3, right? I don't know why they did that. 0 through 1, and then the next one should be 0 through 2. It's going to make these intervals different widths, but I guess that's okay. That can happen in a histogram. You can have different widths, so those really unlikely, I think. Sorry, so I'm rambling. 0 through 3 is now here. So we include this larger interval at 10. Okay, and you would color that in neatly, I hope. I'm just rushing. 0 through 5 is 17. So here's 18, 17. It's here. Okay. Sorry, use a ruler for this, please. Okay, and then the last interval is all 20. So you can change the widths of your intervals, although it is nicer, I think, to have a consistent width in most cases. So your cumulative, in general, your cumulative diagrams, I can't imagine one that wouldn't build up as you go, but that's how they generally work. Okay, next one. Test scores, right here, construct a box and whisker plot to display this data. So this is interesting because we can use a graphing calculator to do this really quickly. So let's just do that. We go to our stat, press edit to edit our list. We have a list here. Let's clear it. Go all the way to the top, clear, and then enter. That clears our data. And then enter our data in 72, 73, 66. This can save you a lot of time. 71, 82, 71, 82, 85, 95. Always check that you're entering them incorrectly. I always mess that up. 85, enter. 86, enter. 89, enter. 91, enter. Was done. And 92, enter. Okay. So now all of our data is in. We just want to set up a stat plot. So we hit second, stat plot. Make sure that you have a plot that's on. Put it on and select the box and whisker plot. Oops. You have to scroll to the right on this calculator until you hit this icon right there. And then it wants to know what the X and Y lists are. If you press enter, it's only going to give you an X list because you only need the X list. And the frequency is going to be 1 unless your data points are appearing more than once. But I'm not going to use that here. Hit enter. Okay, we got that. Now this is, I think, throw some people off, but you actually want to pick zoom to get this thing. And then there are lots of zoom options. Right, I'm going to scroll down here. What you want to do now is zoom stats, option 9. Hit enter, and it draws the box plot for you. So now you have this, but what's even nicer is that as you hit second, I think calc it is, hit value, you scroll through it. Oops, no, that doesn't work. Press zoom 9 again, apologies. You can actually scroll through this thing. Oh no, how do we do that? There's trace. Yes, sorry, I was talking to myself there. If we press the trace button, it kind of hops through the different points that are really important. For example, it goes right over to the median. So now we know our median is at 85. So we have that line is right there. That's our second quartile. Q2 equals 85. Got that? Next. Q1 is 72.5. So we have this point right here. Q1 equals 72.5. And we're almost done. The minimum is 66. Okay. So a little line right here, 66. And the excitement is building up. Okay, Q3 is 90. I'm just writing these in for myself. And then the maximum point is 95, which of course it is. On the list right here, there's 95. So 95. So now it's literally just connecting these lines. And that's it. If you don't like doing this, what you could do is you order the list, you find the median. That's your second quartile. Then you take the lower half and find the median of that. That's your first quartile. Then you take the upper group, right, and find the median of that. That's your third quartile. And then you just plot everything else. But some of the nastier ones, the graphing calculator can really help. Okay, let's keep going. We're making progress here. Okay, the number of hours spent on math homework each week and the final exam grades for 12 students are plotted below. Okay, based on the line of best fit, which exam grade is the best prediction for a student who spends about 4 hours on math homework? Okay, so I want to attempt to draw the line of best fit. There we go. The line of best fit is a minimal distance from the most points. Doesn't mean it goes through the most points. It doesn't mean there are equal number of points on both sides, but you should try to minimize distance to all the points. So let's see if we can get a good approximation. 4 hours, right, should lead us up to the line about here. And that's at about between 70 and 80. So here I'd say 72 is a great approximation for what you should expect, right, to get, about 72. So between 70 and 80. And this line could be slightly up or down from here, but it's going to be pretty close to that point. You could find that this precisely by entering the points into the calculator, but that would be super tedious. Okay, Alex earned these scores. Okay, blah. And what is the relationship between the measures of central tendency? Okay, so here I'm going to go back to my list function. Stat edit. I'm going to use list 2 and 3. Sorry, list 2 here. So our values are 60, 74, 82, 87, 87, and 94. Okay, so I don't actually know how to use the calculator for a mode, although I'm sure there's a way to do it. But let's just point out that the mode here is 87. So that's going to help us. So mode equals 87. What does the mean equal? That's where the calculator comes in. And what is the median equal? Do it really quick. We go hit second stat, math, mean, choice 3. Oops, I didn't enter the list. Do it again. Second stat. Oh boy. I'm hitting all the wrong buttons now. Second stat, math, mean, and this is list 2, so second 2. And we get 80.66. Okay, so that's the mean, 80.6 or 80 and 2/3. And then we go to the median. So we hit second stat, math, median is choice 4, and then second 2 for list 2, 84.5. Okay, so now we just compare these. The mode's the greatest, and the mean is the least. So this can't be correct because the mode should be the greatest, right? Mode is then the median, the mean. This is the answer right here, choice 4. Okay. Okay, so I marked this question a little bit, but let me explain. They're selling tickets here, and these are in hundreds of tickets. And I started to mark down what each of these lines represent. This line represents the first quartile, or the lower half of the data, or the 25% mark. This is the median. This is the third quartile, or the upper quartile. Here's our maximum number right here, and here's our minimum number. So the second quartile is not 600. The second quartile is this line right here, 400. The mean is not 400. The median is 400, so that's out. The range is not from 300 to 600, not from these two lines, but from the min to the max, or 800. And 25% always is between the first and second quartile here. So this is 20. Let me just highlight that. The distance between this first and second quartile is 25%. The distance between the first quartile and the minimum is 25%. In fact, all of these ranges, this is 25% from the second to the third quartile, and from the third quartile to the max is also 25%. The box and whisker plots split your data up in these 25% intervals. Okay, the number of songs 15 students have on their MP3 players is the following. State the values of the minimum, first quartile, medium, third quartile. Okay, so and then we construct we're constructing a box and whisker plot. So let's go to our stat. We want to edit, and this will be very tedious, but we can enter these right in. So here's our numbers: 120, enter. Okay, got that. 124, enter. 132, enter. 145, enter. 200, enter. 255 and 260, 255 and 260. Okay, 292 and 308, 292, 308, enter. 314, enter. 342, okay, we're getting there. 407, if you haven't fallen asleep yet. 421, enter. 435, enter. And 452, enter. Okay, whew, got them all. Now we quit out of this. Now we make sure we go to second stat plot. Okay, my first stat plot is on. I'll check that. I've got the box and whisker plot set up. Fantastic. Here, though, I have to change this. The list I want to use is not list 1, but list 3. So here we clear this, I think. Yep. Second 3 for list 3. Enter. Great. On zoom, it's the 9th command for stats. Although I have to quit this, sorry. So zoom 9, zoom stat, and you'll get your box and whisker plot. Now, here, this will highlight the key values for you to save you so much time. The median is 292. It shows you that. Just press the trace button to find that out. So 292 and 145 is the first quartile. So let's just take a look at this. The minimum value is 120, I believe. Let me just go back to my calculator and check. Right, it is 120, and we have to go up to what number really quick? Oops, we're out of power. 452. 120 to 452. So let's quit this. 452 minus 120. I can just do it in my head, sorry, but I'm typing it in. It's 332. So if we go by tens, that would be 33 intervals. That's not very nice and friendly. Let's go by 50s. A little sloppy, but it'll work. So 120, 170, right? And then 220, then 220. By 50s, 270, 320. So every 2 is 100, right? And then, sorry, 420, and then 520. Okay. Okay, now we got it set up. We're going to be estimating, but it'll work. I'm just wondering if it'll look terrible. Maybe we'll go by 25s. Sorry, that's annoying. Let me fix that. Okay, so now we're going to go by 25s. So I'm going to use my whole space here. 120. Sorry about that. Up by 50, right, to 170. Up again, 25 and 25 is 220. 25, 25 is 270. 25, 25 is 320. 25, 25 is 370. 25, 25 is 420. 25, 25 is 470. 25, 25 is 520. Okay, that'll be better. So, sorry about that. Go back to our zoom, 9, enter, and just press trace. Okay, our key values. The median is 292. So we mark that line. Let's change colors here. 292 is about here. So Q2, and just label it so they can't get you any points here, is 292. Next. Q1 is 145. So here's 170. Here's 145. Double check that. 145. Okay. It's this line right here. Q1 equals 145. Keep going. Q3 is 407. So here's 390. 407 is about right here. Q3 equals 407. And the minimum is 120 right here. And the maximum, I can't remember that, is 452. Okay, so here's 420, 440, 470, 452 is right here. You can label that as 452 equals max. All right, so you just draw the lines in, set this box up, and you're done. All right, keep going. Which phrase best describes the relationship between the number of miles driven and the amount of gas you use? Okay, so the more you drive, the more gas you use. So it's a positive correlation, and it's a positive correlation, so it's correlated, and it's causal. All right, one leads to the other, so it's causal and correlated. Both choice 3. All right, we're getting there. We're gonna move quick because I'm pretty low on battery power here. Let's see if I can do this. All right. The school store did a study comparing the cost of sweatshirts with the number of sweatshirts sold. The price was changed several times, and the number of sweatshirts. Okay, so they're adjusting the price to sell more sweaters, and we want this to match this. So the cost of sweatshirts, as the price goes up, they sell less. That makes sense. So when the cost of sweatshirts was $10, right? They sold 9 shirts. So this one's out. 10 is at 5. 10 is at 9. Okay, this one looks good. 10 is at 15, that one's out. 10 is at, so it's one of these two. At 5, though, it should be at 14, and here it's at 15. It's too high, so the choice is 3. What I did there was just look at these, use these 2 points to pick choices that could actually work. And oh wait, I made a mistake. The numbers sold. Oh no, okay, sorry. These switch the axes, so I was confused for a moment. Just check 2 points and see what fits and what doesn't. Last problem. Oh boy. The Fahrenheit temperature readings are here. Okay, construct a frequency histogram based on the tables. So we're literally just counting these. I think I can make it for time. although I'm probably going to make a mistake here. I usually do. 40 through 44. So let's count those. 1, 2, 3, 4. Okay, I get 4. 1, 2, 3, 4. All right, next. 45 through 49. So let's find those. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 50 through 54. 1, 2, 3, 4. 1, 2, 3, 4. 55 through 59. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. 1, 2, 3. 60 through 64. 1, 2, 3, 4, 5, 6, 7. 4, 5, 6, 7. This is very tedious, sorry. 65 to 69 is 1, 2. 2. 1, 2. So 2, 7, 8. Although now I'm worried, I thought I said 9 there, but we'll go back. 8, 4, 5, and 4. So how many in total? We have 9 plus 4 is 13, 21 plus 7 is 28, 29, but I believe we have 30 here. Let's count. 2, 4, 6, 8, 10, 12, 14, 16, 18, 22, 4, 6, 8, 30. I think my mistake's here, 55 through 59, so I'll check that one. We're getting low on battery power here. Interesting. 55 to 59. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that one's okay. 40 through 44. Go through them all again. 1, 2, 3, 4. Okay, that one's okay. 65 to 69. I'll take that one. 1. Oh, sorry. 2. 2. Okay. 60 through 64. 1, 2, 3, 4, 5, 6, 7. Jeez. 50 through 54. 1, 2, 3, 4. Must be the last one. 1, 2, 3, 4, 5. Oh, I must have added wrong. Oh, that's embarrassing. Okay. 9 plus 4 is 13, plus 8 is 21, plus 9 is 30. Oh, yes, that's 30. Okay. Now I have 1 minute to do this. Let me pause this. Okay, so I set up this frequency histogram. I'm just going to explain it really briefly. Notice that these bins down here, the intervals, kind of match what we have up here in the table. It just looks slightly different. I go from 40 through 44 and then up to 49. Here goes 40 through 44 and then 45 through 49. The reasoning is just, in all of these bins, the way I set the intervals up is to include all the data in each interval. And that means that 40 through 44 is including every number from 40 through 44. And if you get 44, I rounded it down into this first interval. But what about 45? Where would that go? What about anything larger than 44? Well, it all goes in this bin right here. And anything larger than 44, but less than 49, right? Oh, sorry, 44 up through 49 is included in this interval right here. So we've taken care of that. If it's 49, it gets rounded down into this interval, not up into the next bin. So 49 through 54, that includes everything larger than 49, which is 50 through 54, and up and through 54 gets included here. Next interval is above 54 but less than 59, which is 55 through 59, and so forth. So set these intervals up to account for all of the numbers that fall into each group. Thanks.